In this lesson, we are going to begin looking at now different properties of our integral, specifically the definite integral. So this problem is actually review. We're going to use this to answer these questions here. So go ahead, pause the video, and get the areas here on your own. And here we go. So here you should have gotten an area of 2 pi, right? Because this semicircle has a radius of 2, which again, pi r squared, but then half it. So 2 pi. Then here you could have split up this trapezoid if you would like, or find the area of the trapezoid here into an area of 2, and an area of 1, right? Because base times height, half that. Then here you could split this triangle up into 2 triangles, or again, just do base times height for this entire triangle here, but I'll go ahead and separate it just in case, with an area of 1 and an area of 3. So here, now for those who did not split it, you should have gotten a total area of 4, because here you have a full base of 4, height of 2, which is 8, and half of that. So then here, this is our definite integral because of our boundaries here. Notice how we're focusing on the entire graph, right? The x values of 0 to 12. So from 0 to 12, we're looking for the area under the curve of our function, f of x. Now, this dx here, so we understand the notation, this means what we are integrating with respect to. So this is, we're finding the area of f of x with respect to x. So that is what this dx is here for. So it's telling us what we are integrating with respect to. So here again, so 0 to 12. Again, remember this is our positive and negative values. So you should have gotten here for this review question 2 pi plus 1, right? Because again, this is 2 pi plus 5. These are all positive values, 2 pi plus 5. And then here, this is a negative 4 value. So here, that's how you get the 2 pi plus 1. Now, this is something new here. This is one of our properties. What do you notice? Well, you should notice how the boundaries are switched, right? We're not going 0 to 12. This is our form here, how it's increasing. But notice how this is 12 to 0, like we're working backwards. It got flipped. So here in this case, whenever we're going backwards from 12 to 0, like we're decreasing, we are going to take the opposite sign. So now here, this negative 4 is now actually positive 4. This positive 5 is now negative 5. This positive 2 pi, because it was above, is now negative 2 pi. This is one of our properties. So here, going from 12 to 0, going backwards, we end up with negative 1 minus 2 pi, which if you notice, we change the signs of our answer from 0 to 12. So again, this is one of our properties. This is a reversal property. So here, again, our definite integral. So here is our integral sign, right? So with our boundaries, focusing on finding the area of the curve from A to B. Notice again that increase. This f of x here is our function, or we could say our integrand. And then here our notation tells us what we are integrating with respect to, what variable. So again, in this case, with respect to x. So again, notice this is our form, right, of our integral a to b, that increase. So with our reversal of b to a, remember we switch the signs. So this is like saying we're going to take the negative value of our original a to b of f of x with respect to x, so dx. Now, Another property is our equivalent. Notice how it stays the same, a to a. So if I want to know what is the integral here, then that value is just 0. Because if you think about it, right, like I'll go back to the graph, but let's say we're going to focus on 6 to 6, right, of our function with respect to x. So if I say 6 to 6, well, this is 6 to, well, 6 itself. Is there any area? Did we make any figure here? Or are we finding any area under the function? No. So that's why here our value is 0, or the area under the curve. Then our constant multiple, where k is a constant that we are multiplying by. Well, that is the same as just multiplying our area under the curve from A to B by that value. So again, let's say we're going to focus on, and we'll go back to it, let's say 6 to 7. All right, we'll go back to our graph of 5 times f of x dx. What we're saying is that this is the same as 5 times the area under the curve from 6 to 7 of our function. So the area under the curve from 6 to 7 is 2. So we're saying this is the same as 5 times 2, which is 10. That would be the area. Then adjacent property. This is stating here, notice A to C plus C to B. Notice how we have this common value here. So if A to C plus C to B, then that is equal to A to B. And the same applies going the other direction, that we could split this into our two integrals being added together. So like, for example, how we were focusing on 0 to 12, our 0 to 12 f of x, when finding the area, that is the same as, let's say if I wanted to know 0 to 4 plus 4 to 12. So again, this is our property where we could take these values, add it together, or split it up our 1 into our two integrals. Then addition as well as subtraction. So if we also had subtraction, this is our property where we can split. Notice how it's two different functions. So this is the same as a to b of f of x plus a to b of g of x, of the other function. So again, we're saying that this one integral where we're adding the two different functions together is the same as we split up those two values. And the same applies if this was subtraction. So this is the same function. So I'm going to go ahead and add in, but you already have it. So 2 pi, 2, 2, 1, 1, and 3. Okay? So now here we go. Notice this says not 6 to 7, but 7 to 6. So this is the reversal. So here the area of 6 to 7 is 2, so 7 to 6 is negative 2. So again, we're taking the negative of the original integral area under the curve. So again here, same thing. We're going 12 to 8, which is our reversal. So there's two different ways because we also have our 3. So this is the same as 3 times. Now, we could say negative 8 to 12 of f of x, which here this is negative 3 times the area of f of x under the curve from 8 to 12, which is 4, giving us negative 12. Then 0 to 6. Well, 0 to 6, no flip, no nothing. So we're just focusing on the original, but the boundaries are 0 to 6. So here that is 2 pi plus 2. So go ahead and pause the video and try this one on your own. Now this is a little snafu, sorry. This was supposed to be 8, not 9. So 8 to 6. Go ahead and pause the video. And here we go. So you should have noticed that this problem was a lot like the example 1b, where we had the reversal and multiplying by 2. So this is the same as 2 times, but let's go ahead and reverse. So negative 2 times the area from 6 to 8 underneath our function. So from 6 to 8, which is from here to here, you have positive 3. So negative 2 times 3, which is negative 6. So we'll also focus on using our properties, but without a graph. So this is saying that this has already been calculated for us. We're not doing any calculations. So like here, negative 2 to 1 has an area of 4 for f of x. 1 to 5 has an area of negative 3. And then for a separate function, g of x, negative 2 to 1 has an area of 8. So here we go. From 5 to 1, notice reversal and 4 times our function f of x. So let's go ahead and reverse it. So this is negative 4 times 1 to 5 of f of x. Well, this is negative 4 times f of x is negative 3. So here you end up with 12. Let's do the next one. Now, negative 2 to 5 of f of x. Well, we don't have negative 2 to 5. We have negative 2 to 1 and 1 to 5. Well, negative 2 to 5 is the same as negative 2 to 1 of f of x plus 1 to 5 of f of x. So this is that adjacent property of negative 2 to 1 plus 1 to 5 is the same as negative 2 to 5 because of our value of 1. That's in common. So notice we're adding the two values together. Again, adding, not multiplying. So here, negative 2 to 1 is 4 plus 1 to 5, which is negative 3. So here we end up with a value of 1, an area of 1 under the curve. Then 0 to 1. Now we have negative 2 to 1, not 0 to 1. So 0 is, if you think about it, right, somewhere between here in this interval. But we know exactly where the 0 is and the area. No, we just know that negative 2 to 1 is 4. So this is actually a situation where we don't have enough information. This cannot be determined. So, or we do not have enough information. Last example here. Now notice we've got negative 2 to 1. So negative 2 to 1 of f of x plus 2 times g of x. So we're taking this value here, which again, our addition property. We could say that this is same as negative 2 to 1 of f of x plus 2 times negative 2 to 1 of g of x. No reversal, right? So here, negative 2 to 1, our area is 4, plus 2 times our area of 8. So here, 4 plus 16, which is 20. So go ahead and pause the video now and try these 3 here on your own. And here we go. So for the first one, this was reversal of our function. So the area is not 4, but negative 4. Then here you should have seen that this was our equivalent property of 5 to 5. So even though it showed subtraction, it's still just 5 to 5, which means it's an area of 0. Then here, 1 to 5, no reversal, but using our constant multiple. So 2 times the area, negative 3. So here you get negative 6.